Hey guys, in this video we will be looking at transformations of exponential functions. So let's say we have an exponential function with the form y equals a times c to the power of b x minus h plus k. Alright guys, so a will give us a vertical stretch by a factor of a, and if a is negative, it will cause a reflection in the x-axis. Now let's look at b. So b will cause a horizontal stretch by a factor of 1 over b, and if b is negative, it will cause a reflection in the y-axis. Now let's look at h. So h will cause a horizontal translation, h units either right or left, and k will cause a vertical translation, k units up or down. Alright guys, so now we got the transformations down. So now let's solve our first question, which says that for each exponential function, state the transformations applied to each function in an appropriate order. So our first function, or question A, is going to have y is equal to 4 times 5 to the power of x minus 2, and then minus 5 here. Alright guys, so when listing transformations, we always list out these stretches first. So if we look at this function, we see a vertical stretch first. A vertical stretch by a factor of, it is going to be 4, because 4 is in front of the 5, and it's in the A position. Now, are there any more stretches? No, there is no horizontal stretch since the coefficient of x is 1. Now we go on to reflections, and we see no reflections either, because there aren't any negatives in the A position or the B position. So now we move on to the last step, which is the translations. So we got a horizontal translation by 2 units to the right, and we have a vertical translation, guys, 5 units down. So this is our answer for the first question. Alright guys, this is our second question. We have to list out the transformations of this exponential function. So guys, first, before we list out the transformations, we gotta change this into another form. So let's rewrite this. Y is equal to negative 3, 1 over 2 to the power of, guys, we gotta always make the coefficient of x equal to 1. So we have to group all of them by negative 2, so that our coefficient of x is equal to positive 1 right here. So that will be negative 2x, and this will be negative 3, because negative 2 times negative 3 has to equal 6 when we distribute the negative 2. So this exponential function will need to be changed to this form to be for us to be able to list out the transformations. So now let's list out the transformations, guys. So stretches first. So we have first a vertical stretch by 3, or factor of 3, and we have a horizontal stretch by a factor of 1 over 2, because it's a 1 over b, not b. Now let's move on to the reflections. We have a reflection in the x-axis, because there's a negative in front of the 3, and we also have a reflection in the y-axis, because there's a negative in front of the 2. Now we move on to the translations. We have a horizontal translation, 3 unit to the right, and lastly we will have a vertical translation, 3 unit up. Alright guys, so this is our answer to the second problem. Alright guys, let's look at another problem. For this problem, we have to sketch the function of this guy and state the domain, range, the equation of any asymptotes, and the value of any intercepts. All right, let's do this. So first off, we have to list the transformations of this function. So let's go down here and rewrite the function. So our equation is y is equal to 3 times 2 to the power of x minus 1. So this is basically the transformed version of y is equal to 2 to the power of x, and we have to list out the transformations. So first we have a vertical stretch by a factor of 3, and we have a horizontal translation 1 unit to the right. Alright guys, so first of all, we need to draw this graph of y is equal to 2 to the power of x, and then we have to apply the transformations to the graph in order to graph this guy. So first of all, let's graph the function y is equal to 2 to the power of x. So when x is 0, y is going to equal 1, because 2 to the power of 0 will equal 1, so we will have a point right here. And when x is 1, guys, y will be 2, so we will have a point right here. And when x is 2, y will be 4, so we will have a point right here. And of course, when y is equal to -1, no, sorry, x is equal to -1, y will be half. And when y is equal to -2, y will be a quarter. So it will look like that. And then if we connect the dots, guys, this will go up infinitely, and this will get close to the y-axis infinitely. Sorry guys, it's a bad curve. So now we got the points down. Now we gotta apply these two transformations to the points. So first we have vertical stretch by 3. So we will vertically stretch this point by 3. So that's right now that's 2, 4. But if we vertically stretch it by 3, it will become 2, 12. And if we translate it 1 unit to the right, it will become 3, 12. So basically, guys, we gotta find 3, 12. So we have 3 here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, alright guys, so that will be 3, 12. And now we gotta transform this guy, which is 1, 2. If we vertically stretch it by 3, it will become 1, 6. And if we move it to 1 unit to the right, it will become 2, 6. So we gotta graph 2, 6. So 1, 2, 1, 2, 3, 4, 5, 6. It will be right here. And now let's look at 0, 1 right here. Vertically stretch it by 3, it will become 0, 3. And move it 1 unit to the right, then it will become 1, 3. So we gotta graph 1, 3. Oops, sorry guys. So 1, 3 will be right here. And let's try to connect these guys. Okay, now we have -1, 1/2. Vertically stretch it by 3. It will become this, and then if we move it 1 unit to the right, it will become this. So it will be 0, 3/2, so which will be about here. Alright guys, and our next point is going to be -2, 1/4. 1/4 stretched by 3 is 3/4, and move it 1 unit to the right, it's -1, 3/4. So it will be right about here. So guys, basically this will go infinitely down, same as our original y is equal to 2 to the power of x graph, and it will go infinitely up as well. So we have graphed this guy, which is our function y is equal to 3, 2 to the power of x minus 1. Alright guys, now we finished the sketching of the graph of the function. Now we have to state the domain, range, the equation of any asymptotes, and the value of any intercepts. Alright, so let's write down the domain first, guys. Domain, so this function will infinitely go left, and it will infinitely go to the right, so it will cover all values of x. So basically, guys, for the domain, we will have x is part of the real number system, because it covers all real numbers. And for range, guys, our function goes upward indefinitely, but it stops at y is equal to 0. It never touches y equal to 0, and it gets infinitely close to it. So we say that all y values are bigger than 0, where y is part of the real number system. Alright guys, let's look at the asymptotes. Alright, we will have no vertical asymptotes, but we will have a horizontal asymptote of y is equal to 0, because the function cannot touch y is equal to 0, but it gets infinitely close to it. And guys, how you find a horizontal asymptote of an exponential function is when you look at the equation of the exponential function, and in this case there's no number after the equation. So for example, there is no number here, it's just 0, so we say that y is equal to 0. But let's say there is a vertical translation of +2. Now we will have a horizontal asymptote of y is equal to 2. Finally, let's look at the intercepts. So this exponential function does not touch the x-axis, so it won't have any x-intercepts, but it will have a y-intercept of 0,3/2 because it touches right here, and the y value is 3/2. Alright guys, so yeah, this is the end of this question.